Hello guys, hope you all are doing well. Welcome to my channel Accidental Teacher. Don't forget to subscribe it. Today in this video we are going to do some number programs. Hello guys, welcome back to my channel. Today we are going to discuss about part 2 of number programs. And I'm going to do some programs which are based on breaking a number. If you have not watched the part 1 of this video, please do watch that first before starting part 2. So let's start. Okay, so let's start with the first program. The first program over here is Niven number. So before we start any number program, first thing we have to understand the program. I've told you about that. So let's understand what is Niven number theoretically and then we'll attempt the program. So I have written definition. A number is said to be Niven if it is divisible by the sum of its digits. So that means a number, if you add the sum of digits and if it divides the number completely, then that is Niven number. One example to help you understand. In every program, number programs for ICC, ISC, CBSE or any other board, you will be given one example. So example is very helpful to understand the program. Like example 126. So sum of it digit is 1 plus 2 plus 6, which is equal to 9. Now 126, the number which is given by the user, is exactly divisible by 9. So that means 126 modulus 9 equals to 0. So you can just check that whether 126 is exactly divisible by 9 or not. It is. So that means it is a Niven number. So basically what we are supposed to do in this program, we are supposed to find the sum of digit first, which we have done in the previous part. In the first part I have shown you how to find the sum of digit. We will do that, and then after that what we will do, we will check whether the original number is exactly divisible with the help of the mathematical operator modulus. Now moving on to the program, I have taken some variables. I have taken all the variables like int r, n, c and s equals to 0. Now over here I think you already know what is r is for the remainder, n is to take the value from the user and then use it in the loop as well. C variable over here is a new one which is used to keep the copy of the original number. The number is n. To keep a copy of n we use c, and I'll tell you why we are using that also. And s is for the sum of digit. We have to calculate the sum of digits, so that's why we are taking s equals to 0. After that, we ask the user to enter any number and that will be stored inside n. Now what happens, whenever we are using the loop, you know that the value of n at the end of the loop is 0. But in this program, what is given, the original number is required again, because we have to check the original number modulus the sum of digits to check whether it is Niven or not. So we need the original number, but the original number n after this loop becomes 0, so we cannot take that. So what we do is, instead we create a copy where the value of n, suppose is 126, the value of c will also become 126. After the loop, the value of n becomes 0, but the value of c is 126, and the variable c can be used to check whether it's exactly divisible by sum of digits or not. Now, in the loop, you know, till here, these things are compulsory, like r we are taking the remainder, n is to break the number, like to decrement the number when you are dividing it by 10, and s to find the sum of the digit. So this program we have done earlier also. So at the end of the loop, suppose the number is 126, the value of s becomes 9. But the program is not complete over here, because we have to do the last step. So for the last step we are using if-else statement. So in the if-else statement, what we will do is c, which is the copy of the number, modulus s. So c modulus s, if it is equal to 0, that means it is a Niven number. So if this condition is true, it will display it is a Niven number. And suppose the condition is false, that means the sum of digit is not exactly dividing the number. Then it will go to the else part and display it is not a Niven number. So this way we do the program Niven number. Now over here I have not explained much about this thing, because this thing has been explained in part 1 also, where we are learning how to calculate the sum of digit. And you have to remember, most of the programs that we are doing in this part, not most, all the programs we are doing in this part, this technique of breaking the number will be used. The second program today we are going to do is Armstrong number. So let's understand the program first. Armstrong number, the definition, a number is said to be Armstrong if the sum of the cube of its digit is equal to the original number. So this is the definition. So basically we have to take out the digit and then find the cube of each of the digit, and then we have to add and check whether they add up to the number itself. Like one example. Example 153. 153 is an Armstrong number because, let's see, 1 cube plus 5 cube plus 3 cube. So all the digits we have to take out the cube and add them. So 1 cube is 1, 5 cube will be 125 and 3 cube will be 27. If you add them, you get 153. So when you are adding the cube of the digits, you are getting the original number. Now we have understood what does Armstrong number mean. So we'll try to implement this in the program. A few things we'll take a note of, like, do we need the copy of the number or not? So if you look at the example, we do need the copy of the number because at the end, when you are adding the cube of the digits, you have to check it with the original number. So we do need a copy. So R and N we are taking it for the remainder and number. C we are taking a copy because we need that. And over here I have taken S to find the sum of cube of the digit. Now you all know what is a cube. Cube means to multiply a number 3 times. So two techniques are there. One is you can multiply it with the help of multiplication, like R into R into R. You get R cube. Or you can use the mathematical function math.power R comma 3.0. But if you are using a mathematical function, then over here what you are supposed to do is you are supposed to do typecasting. So you have to convert the math.power from double to integer. So I don't want to do that in this program. So that's why I have used a simple technique. I am just multiplying R into R into R. So the variables taken over here, you have already understood. We are taking the value of n from the user and then we are making a copy because we need it later on. And we are using the loop. Now inside the loop, the remainder is n modulus 10. We are breaking the number and then we are dividing the number by 10 so that the number decreases. At the end the number becomes 0. Now this is the part where we are implementing the Armstrong number program. So what does the program say? We have to find the cube of the digit. So cube means what we are doing, the digit is stored inside R. We know that. Always the digit one by one is stored inside the variable R. So I have put a bracket so that you don't get confused. So what we are doing is R into R into R. Suppose the number is 153. So the first number that comes will be 3. So it will be 3 into 3 into 3, which is 27. That will be added with S. Next time the value of R will become 5. If you take the example 153. So 5 will come over here. 5 into 5 into 5 will be 125. So 125 will be added with 27. And that will be 152. And then at the end R will become 1. So 1 into 1 into 1 is 1. And 152 plus 1 is 153. So 153 is stored inside the variable S. So after the loop is over, now again we have to use the if-else statement. Over here, the copy means the number 153. If copy of a number is equals to the sum of the cube of the digits. So here copy is 153, sum of cube of digits is also 153. So the statement becomes true. True means it will display it is an Armstrong number. And suppose the sum of the digit is not equal to the number, then it will go to the else part. If this statement is false, it will go to the else part and display it is not an Armstrong number. So basically only few things we have to change when we are doing similar type of program where we are using the technique of breaking a number. I think that you can notice over here in this program as well. So this is how we complete the second program. Now I will be doing one more program, the last one for this part. So the third program is pi number. It's also known as sum product number. So let's understand the program first. A number is said to be a pi number if the sum of all the digits is equal to product of all the digits. So that means over here we are going to do two things. We are going to find the sum of digits as well as the product of digit. And then we are going to compare them and check if they are same. If they are same, it is a SPI number. If it is not a SPI number. Let's check one example. We have example 132. So if you find the sum of digits 1 plus 3 plus 2 is 6. And the product of the digit is 1 into 3 into 2. I have used the same number. So 1 into 3 into 2 is 6. So you can see the sum of the digits and product of the digit is same. So sum of the digits equals to product of digit. If this happens, that means it is a SPI number. Now, few things over here, like, do we need a copy of a number for this program? If you look at it properly, we are not using the original number again in the program. Like over here, what we are doing is we are finding the sum, we are finding the product, and then what we are doing, we are comparing it. So we are not using the original number. So a copy of a number is not required. So we don't need the variable C. But look at the program. We have used R, N, S. Now R is for remainder, N is for the number, S equals to 0 for sum of digits. Now in this program we also have product of digit. So for product we are using a variable P equals to 1. Now why we are using 1? Because product means to multiply. If you use 0 over there, no matter how many times you multiply, the answer will always be 0. Because 0 into any number is 0. So that's why for product we are using 1. Because 1 into any number is that number. Now we are taking the value of N from the user and then the while loop. In the while loop, just have a look, R for remainder, N to reduce the number, dividing it by 10. Now look at this, we have two things. Not only sum, we are also doing the product inside the while loop. So product will be product equals to P into R. Because you know, every time the number, the digit gets stored inside the variable R. So we multiply it with P. And over here, what will happen in the variable P, at the end of the loop, the product of the digits will be stored. And sum, we have already done it so many times. We are calculating the sum. So S plus R, where the digits get add up and then we find the sum which is stored inside S. Now after the loop is over, we get the product as well as the sum. Now suppose the number is 132, the value of P and S will be 6 and 6 respectively. Suppose it is something other than 132, the numbers will be different. So over here, after the loop, the if condition should be like this. If P equals to S. So we are using the equals to operator over here. So P is the product of the digit. S is the sum of the digits. So two variables where the sum and product of the digits are stored. Now if they are equal, that means it is a SPI number. And suppose the product and sum are not same, then what will happen over here? It will go to the else part. Suppose we can take one example, like suppose 12 is a number. So 1 plus 2 is 3. So sum of digits is 3. And product 1 into 2 is 2. So 3 and 2 are not same. So it will go to the else part. And else part will display it is not a SPI number. So this way we do the third program. Now over here only things we have added is we are doing one more operation inside the while. So this is how we complete the program. Thank you guys for watching my video. I hope you liked it. If you have any doubts, queries regarding anything, please mention that in the comment section below and I'll get back to you. The programs done over here are not complete. So if you want the complete program, you can download it from the link given down below in the description. Now very soon I'll be coming with part 3 of number programs, where I'll be doing some more programs based on breaking the number. So till then, stay safe, stay at home and don't forget to stay tuned. Thank you guys for watching my video. If you like my video, please hit the like button and don't forget to subscribe my channel, Accidental Teacher. Now for any reason, if you have to go outside, please don't forget to put this on.